Today I'm going to share my views on the topic of BMS and BTMS, Battery Management System and Battery Thermal Management System. As we all know that EVs is booming in automation industries, new innovations in technology day by day try to improve the drawbacks and performance of the EV. As we know that Toyota is working on the battery pack, which will improve the performance of the electric vehicle as well as the drive range, where Tata is going to launch new vehicles in upcoming year. So this huge, many of the companies which are startup companies and the old one, which is branded companies, are working on the EVs. But still they are working on the performance of the battery to increase the drive range and the safety of human beings. So here the points came BMS and BDMS, which optimize the battery performance, battery operations, and the life of the batteries. So in today's webinar, we will cover these topics. What was the BMS? What was the role of BMS? Functions of the BMS, types of the BMS, how BMS is communicated through a user, what are the reasons behind BMS are failure, what was the drawbacks, and why, how to rectify it, and what was the BTMs, Battery Thermal Management System, and their types. So as we all know that in EVs, we use lithium-ion batteries. The lithium, why we are using lithium-ion batteries? Because of the low self-discharge rate, lightweight, fast charging supportable, but still these batteries are also very sensible and dangerous. If you don't control the charging and discharging of such batteries, they will stop working or maybe swell or maybe explode also from the overcharging. And deep discharging can causes a battery failure also. That's why prefer that battery with the BMS, which can help to improve the battery life, or we can also call this BMS is a doctor of battery. From its name, it's understandable that it is managing the batteries, it's manage the parameters of voltage, current, and the temperatures. Basically, BMS is monitoring the overall parameters of electrics, like how the batteries are function, it's don't overcharge or over discharge, which can don't damage the cycle of the batteries. And we will get a plus point in this BMS that we having a records of data also. So after any of the sudden incident happen, or maybe while in the R&D time, at the time of R&D, we will also do the research and we will check the performance of the battery, that what was the certain cases in which how the battery is reacting. So basic objectives of from the BMS is to protecting and preventing from the damage, for damaging in the electric vehicles and damaging in the life cycles, increase the battery life, maintain the battery system reliability states. BMS is also known as a heart of the battery system because it's monitoring all the parameters. So basically, BMS are the two types, which is one of them is called hardware BMS and one is also called name as software BMS. In the software BMS, it's kind of embedded system where the hardware part is also there and the software part is also there. But in the hardware system, we are looking like a basics functions, like we will prevent the battery from the over voltage, under voltage, and we are providing a continuous current to the batteries, like how the thermal runaway react the batteries and what was the limitations to give the outputs. That's are the basics functions for the batteries. Simultaneously, we are having an advanced function in the smart BMS because smart BMS is having a functions to store the data, and we will see the responses and it will act more smartly. Like when we are connecting them in a string connection, we can easily identify that where was the fault detection. Means we will take a example like we having a 64 cells or 65 cells in one row and column, but how to identify that due to this battery, the cell pack is giving not that certain output, what was the desired output for us. So the smart BMS act very cool in this role, and they will identify that this particular row, this particular column was this battery. Due to this battery only, the cell pack is not getting a proper output. So this type of basics and the smart functions we are getting in the smart BMS. So we will also get the estimations of the state of charge, state of the health of battery, diagnosis, and the cell balancing part in the advanced functionalities. So we will see all these topics in upcoming slides. So we start with the basics functionality over voltage cutoff, where the we will prefer LFP cells. It's a very famous cells in the EVs, LFP cells, which are having a output voltage of 4.2 volt. But we will getting an yes.
Sorry to interrupt, but the presentation is not visible.
It is not visible for all of you or only for you?
No, visible,
No,
sir.
it is not visible at all.
Basically, I get a response from multi-audience like visible, not visible.
Visible है sir, visible.
Okay. Okay. Once try to connect from your side only, because some of your audience are saying that they are visible. So I will carry on from this only. Like we are using LFP cells, which are having a nominal voltage of 3.7 volt, 3.8 volts, but the thermal run will be also there. Like if we going for a overcharging and for the over discharging, like having a overcharging discharge rate of 2.1 volt or 2.2 volts. If we go beyond that, then it can damage the life cycle of the battery also. But in the case of thermal runway, we can see that LFP cells, if it's gone beyond the 3.8, 3.9, the battery is going to heat it. Where in the NMC cells, it's about a 4.2, 4 up to 4 volt. We can see that the thermal runways start in that battery, and maybe that thermal ray go for a overheated or maybe a fire is in that battery. But in the second points come up to under voltage cutoff. Under voltage cutoff, basically a last limit where we can use that battery with a safe handeds. Like we will see the examples, in smartphones, we'll see that our battery, when we are purchasing a new phone, and after 2 to 3 years, 4 years, sometimes batteries are swelling. What was the reason behind the swelling? The reason behind the swelling is deep discharge. You are always your phone is and your mobile is pop-upping you that your battery is going to below the 10%, 20%. So don't go always to for the deep discharge. So that can affect the battery or battery life.
Hello, Jayesh.
Yes, sir. Yes, sir.
Can you reshare your screen?
Okay, sir. I can reshare.
Okay, because some of people saying that they are not getting screen.
Okay. Now my screen is visible to all of you.
Yes, it's visible.
So I carry on with the basics functions of the BMS. So I'm talking about the under voltage cutoff. In the under voltage cutoff, we will see that if we go always the battery up to a deep discharge, it can damage the cycle life of the battery, and it will affect the performance, and it will also maybe affect in the optimizing performance of the battery for the drive range and many more. Like we will also maintaining and revolution checks monitoring in the continuous current, because we will see that some of time any internal short circuit, we will see that a certain current is increases at for some interval of time, but that some interval of time also can damage the battery pack. So at that time this battery pack will very helpful. This BMS is very helpful for this, like a 14SCC BMS, which is a one of famous BMS, which can carry up to a 30 ampere current, but in certain conditions, it having a tolerance level of 20%. So it will help very much on that case. Overcurrent detections also for a short period time is one of the plus point for the BMS. And when we come towards the temperature, like when we are going batteries for the thermal runway and the heating generation, basically whenever the electricity due to the chemical reaction is generated through the battery, the heat is also produced on that battery. So that heat is we will affect that battery from the internal side also and as per the external side of the batteries also. So at that time we will monitor the internal temperature and external temperature, both of them, which is suitable for the battery. So that temperature is maintained during the charging and discharging of the batteries also. So that parameters was taken by this over temperature cutoff sections where like 40 degrees Celsius. Like 40 degrees Celsius is sufficient for the charging time. While when you are going to discharge, you can go up to 57 degrees Celsius or 58 degrees Celsius also. So it will not going to stop the battery pack or simulation part. But if you go beyond that time limit or your their performance limit, so you have to move on that. Like a BMS is also having their selection performance, like how we can select the BMS and what were the basic standards to select the BMS. So for the, it's very dependable that what was the grade of battery or what are the C rating of battery you are using on the battery pack and how you are going to select that battery. So I will tell one example of a battery pack, like how I will select this battery for this entire battery pack. This is a one of a battery pack who's having a 6000 AMH battery and LFP cells and is having a 12 cells. And this 12 cells having a discharge cutoff voltage of 2 volt and the charging voltage of 3.6 means it's giving a nominal voltage of 3.7 voltage output also, and this charging voltage recommended it should be also 3.67 volt on. So at my preference, that is a good range, like a 3.7 volt is charging rate for that battery is good. And the temperature range should be while it's charging and discharging should be for this battery pack is 0 degree to minus 40, 0 degree to 45 degree of Celsius. So as per this basic terms parameter, you can select the BMS. Like first of all, you have to see that how many number of cells you are using for that BMS, like a 16S BMSs.
Jayesh, are you there? I think you are muted.
Hello,
Yes, now you are
now I'm
audible.
audible, sir.
Yes.
So I'm starting with
Hello.
the hardware BMS. Yes, hello. Yes, if you have any query or shall I proceed?
Sir, I have one question like related to battery management system. Can I ask it right now?
Yes, yes. Go on.
Sir, I just want to know about like for the SOC calculation, we use multiple types of filters, and one of the efficient filter we see is the Kalman filter. So, what are the algorithms and the parameters we take at the initial stage? Can you please tell me about it? Hello, am I audible?
your point. I got your point. Hello.
Yeah, yeah, sir.
Yes,
I,
basically
I,
the
uh,
SOC estimation part covers about the real life implementations. So we will take the state of charge, DOD, and SOH. What are the performance what are the performance parameter of the battery cell pack as per the C rate of the battery pack design, and on that basis we will select that battery pack. And for the algorithm part also, we will go towards the what was the case scenario that how the battery pack will react. So at the time of SOC, like what was the driving range capacity for the initial part, and what was the driving range capacity when we are going for the peak time. So that was you have to take the estimation of that topic or that part. That's where part of another SOC estimation when we are going to design the BMS for a smart BMS.
okay,
I
sir.
hope it's clear.
Yes, sir. Like we are designing one of the BMS, that's why I'm just asking about the
Yeah,
filtrations and all.
like you are using the MATLAB software for the algorithm functions, or
No, sir, we are not
maybe
using. We are making a hardware BMS. So
okay.
simulations we are using every circuit, and for the practical
Basically,
applications,
for a single cell, or maybe if you are choosing for the
it's a
battery pack
15S.
designing, 15S. Okay, so basically you are connecting them in the string connections. When you are going to connect them in string connections, like in the if you are going for the hardware form, if you will go for the hardware form only, so you don't have to that much too much trouble. Like you have to take up basic circuits, and you can go through the configurations and how the MOSFETs and what was the IC form, how the logic gates are reacting on that condition. Like when we are going for a high voltage, so it will go to pass for the cell balancing techniques, like that type of configuration. Once you cover all that topic, so you can easily go for the hardware implementation part also.
Mm-hmm.
Okay. Okay, so I will carry on from for the next topic.
For sure, sir.
Okay. So this is one of the hardware BMS. In the hardware BMS, the basics components are active component and the passive components. The active components are this IC, integrated circuit, which is the basis on there, the logic gates and what was the special purpose for the designing. And this MOSFETs, there are MOSFETs where basically the function of MOSFET is as to trigger while in the charging and discharging parts. These two parts are the active components in this BMS circuit, and they are having a lot of components, like a 700 nano components are available on that BMS. So the resistors, transistors, and diodes are connected for the cell balancing, where this red color box was connected for the charging MOSFET, and yellow color box is for the discharging MOSFET. But how you can easily identify that is a discharging MOSFET due to the shunt reactors. The shunt reactors are connected to the discharging MOSFET always. So basically, while in all the also in the connections of the BMS also, you always have to connect the negative power supply of the battery pack to BMS. Okay. Uh, Basically, some of one having a mic is on. So is if you have any questions, so go on, or I will move forward. So please turn off your mic. So we are talking about smart BMS. So what are the advanced
Jayesh, please unmute yourself.
hello?
Yes, you are audible.
Yes, sir. Now it's audible. You can carry on.
Okay. So I'm going with the advanced functionality, where the we can also call as a functionality of the smart BMS. What were the advanced functionality? of the current, voltage, and temperatures, and they can report that data to the BMS, and BMS can evaluate that data and shows about the SOC, thermal management, optimization of power, and they can through the data into high level language through the CAN communications, or maybe like for a small vehicles, we can also see that in the configurations of through the IoT cloud base also or the Bluetooth base also. We can cover that topic also. But we will start with the shows the state of charge. State of output or what was the charge which is present, which is useful for us. Like a battery is having a 4.2 volt, but we can use the basically voltage from 3.8 volt to 2.2 volt only. We don't go beyond that 1.8. It is very affect the battery to damage for their life cycle and the lifeline of the battery also. So we don't go
Yes, you are muted again.
sir, something is happening all
Okay,
I don't know,
just
but
I will make you co-host. If you receive a notification, then ignore it. Okay.
okay, no problem, sir. Okay, so now I will proceed, and I hope now I am audible to all of you. Once a response,
Yeah, you're audible.
yes, okay. So we are moving toward the communication interference. Like I told that we are using CAN communications and Bluetooth communications, so we can optimize, we can evaluate, and we can show whatever the performance of the battery pack. So this is a part of the communication interference. It's also come like a cell monitoring and diagnosis. Like cell monitoring, like we having, I told that we having a number of the batteries, but how you can identify that due to this battery or due to this particular road we are facing some issues, so how can you smartly act on it? So that's all are the control come under the smart BMS, data logistics and reporting. This was a very useful for the companies who are checking the algorithms, who are designing the algorithms, so they can easily understand that what was the problem faces by the batteries, and why the batteries, like some of time when you are going to charge your battery fully you have charged, like it's battery is showing that is 100%, but after if you are not using, then also after 2 hours 3 hours there is a drop in voltage drop, or maybe you can say as a charge drop in the battery. But why, what was the reason behind that? So whatever the reasons for that or the issues you are facing, they are coming all the data stored in the data logistic part, so you can easily evaluate that part. Cell balancing, it a self balancing also having a active cell balancing and passive cell balancing, but we will prefer the passive cell balancings in the hardware part, in the software part also, because the active balancing having some complexity and the cost efficient. So we are moving, so these are the basics parameters for the smart BMSs. So we are going to cover all the basics fundamentals. Like I will show one of the pictures of smart BMS. You can see that we are having a fans also along with the heat sink for the thermal runway. We having a thermistors. We having a Wi-Fi connections to Bluetooth connections to connect the Bluetooth and see the responses. I will show one pic of Bluetooth connections response, which I have done in the practicals. So I will show that. Like this one was the picture. You can see that battery pack is having a 15 number of cell, and in each of the cell I am getting a in each of the cell, I'm getting a 3.3 volt from the each of the battery pack, like a nominal voltage. But in some of battery, like it's getting a 3.52 volt. But something is happening in this battery, or some of the batteries are going to the deep discharge. So you can easily identify that which of the batteries is having a issue. Like you can see that batteries are connecting string connections. And in still this condition, what was the maximum output? Like 3.52 volt is the maximum voltage, and the minimum voltage is 0.7 volt we are getting from that battery pack. So the fault alarm is also indicating through the Bluetooth communications. So we'll talk about the communications, how to connect with the battery BMSs. Like yes, like CAN communication, Bluetooth connection, IoT based, like CAN communications. Basically, it depends upon the allow to microcontroller to device to communicate with each other. Like what are the responses? It's basically directly not connect with the BMS. It's first off connected to the VCU, vehicle control unit, and then it's connect through the CAN communications to the user, so they can see the responses, that what was the SOC of the battery, and how while in the regenerative braking also, what are the we are getting a power while in the regenerative braking charging, are somehow it is looking from the BMS also. So the second topic is Bluetooth. Basically in Bluetooth, we send the data to end user through their cell phone apps. So while this is basically, you will see in the three-wheelers and two-wheelers where we can see the performance of their string connection of battery, like iCloud system, where we need a separate wireless internet communications where can data can transmit to the signals, and we can evaluate the simulation part, like what are the problem and what was the current scenario of the battery. So this is a part of the smart BMS, and it is very helpful for us. Like I told that we are using the CAN communication. So when we are going to CAN communication, basically while the charging, discharging, and the cell balancing part, we will evaluate the performance, and basically we are giving that performance to the BMS through the data logistics. They can understand the response of state of charge, state of earth. They basically are monitoring whole battery pack system, and then they are sending the response to canvas to communicate the data to the user. Like we are using in four-wheelers also a CAN 2.0 BMS to send the communications data from battery to the vehicle control units. So along with that, we have seen that cell balancing. What was the cell balancing? Basically, we can see that without the cell balancing, we are connecting the batteries are in the series connection, parallel connections, and we can select the batteries like we're having a C rate, a basic common C rate. Along with all that types, we are going through the active balancing and the cell balancing. But in the passive balancing, we can see that the resistors and diodes are connected to the each of cells, and that each of cells, like in the BMS, they are having a lot of wires in the secondary part. We can connect it the wires to each of the cell, and they can evaluate and they can check the responses of the cell. According to that only we can transmit the power, or we can disconnect the power in the passive balancing. Basically most of the BMSs are in the passive balancing only, but active balancing is one of also a good part. Basically in this one, electronic circuits are used to redistribute the energy, but it can also affect the life cycle of the battery, because it always maintain the full power supply, and you can see the performance difference between active balancing and the cell balancing in this chart also. So I will move forward. Like what are the reasons of the BMS failure? So you have have seen some of the videos, some of the photos, that and some of the trust issues also in the e-bike, that why the fire catches in the vehicle, and what are the how you can trust that vehicle, because certain body is getting heated due to the BMS failure. One of the major causes is BMS failure. Like most of the time when the servicing, at the time of servicing, or they can find that the BMS is having a major issues, like MOSFET is not working properly, or the ICs which are placed in the BMS circuit are not placing the current demanded. Like a EV motor is demanding a more current, but somehow some assembly line companies have uh, connected the motor which is unregulated and which is inefficient for that, or maybe having some more losses, heat losses on that motor. So like we need a regulated current power supply to the EV motors. So this was the reasons for the catching fires in the two wheelers. Like we one of the most reason that a EV regenerating braking also. Like BMS is having a not designed for the regenerative braking also, and some of the four wheelers like they are the motor setups are going to design the EVs regenerative energies also. So to better to directly not connect to the battery pack, we will go to store that power in super capacitor, and then from the capacitor we can store that high voltage. After the sum of time, or when the battery is going for the charging power, we can discharge that capacitor, and then we can frequently use that regenerative braking system. So basically we need a super capacitor one setup also in the four wheelers. So that was the some basics reasons why the we catch fires, and what was the solution for that. Like we'll avoid to using unbranded things, like just it's a cost efficient, or maybe you can go for a you have to pay like a Chinese product, or maybe you are paying less money for that component. So always try to take a high quality of components while the designing of BMS also. And what was the component which is having a BI start mark, and choose the motor, any of the components, or we can voltage draw, or we can deliver the power to the any of the components. So check the current rating, voltage scenarios, and what was the specification of that component. According to that only you can prefer like this type of battery pack, and what are the features we are getting in the battery. So choose that path, so you can see that the less of the BMS failures, and we can see that the less of the catch fires also. But along with that also, we can see some the reasons of catch fire is also a poor quality of lithium cells also. Like we are using the lithium cells. Basically, lithium cells are originated from the two parts, through the mining or through the usable. You can use as a secondary type. Like the grade of material should be a less. Like when once it's used against it for the recycle, and then you are using, like, then the purity of the lithium should be less. So you will go for a grade C or D grade. So try to select that battery is having a best grade quality. Like we will see all that parts in the BTMS, like how the BTMS is also work, like to rectify all that. Like the battery thermal management system, from its name says that it works or it manage the thermal, like a heat of the battery. When we are when the electrochemical reaction act on the lithium ions, react from anode and cathode, so the some heat is also generated in that battery pack, or to each of the cells. So how to provide a solution, like air cooling, liquid cooling, there are a lot of things like to how to solve that issue. So we'll cover all that topics in this session. So basically, I'm talking about that the catch of fire. So we also have to improve the BTMS as per the requirement also. Like if we are using for a 16 cell, or for 20 or 50 cell, so you're having a different type of BTMS system. Or if you are going for like to draw a huge amount power, like a for four wheeler, like 36.2 kilowatt power supply for a four wheeler, which having a drive range of 290 kilometers. So for that you can prefer like a hybrid mode of cooling, or like PCM coolings, which having plus benefit of the liquid cooling also. So that type of configurations, like which is used for the pessimistic cells of lithium ion. So we'll talk all these topics in the BTMs. Like I said that BTMS is a very useful, or you can also see that in India, in Indian market, basically we face this type of catch fires because of the temperature, because India is nearby equator. Nearby equator, so the temperature of India is basically at 30 degree, 35 degree as a standard year. But in the foreign countries like Netherlands, Congo, some of the countries which are having a huge market in the EVs, you can see that they are having a climate condition is different. So they use as a BTMS as for the heater purpose also. So they can provide a heater to the battery pack to heat that battery. So we will somehow work on the cooling of the battery also, and somehow for the heating of the batteries as per the climate conditions. So all these topics cover under the BTMS only. Like BTMS having a cell pack of one of the example when the thermal runway in the mid of cell, but somehow it affect on the nearby each of the cells, and after a long time it can affect all of the battery. Like heat can transfer while the contacting with each other. So at that time we are working with the BTMS, like how to rectify this. So for the basic rectifications for the lithium cells, we have to work on that. The gradual of lithium cell is done by the self-discharging of the nominal voltage. Like we have to select the batteries which having a same parameters for the undercut of voltage, under voltage, along with the lithium grade quality, C rating of the batteries. So we have to look on this major issues. Secondary, with the coming of the nominal voltage range, we have to check the improve the qualities of the each of the components like resistors, capacitor, MOSFET, diode. All are the components which are from branded companies product. Like many of the companies nowadays are working on the BMS designing with the algorithm which can sudden react and can sudden response, or if they are facing some issues in the EV, they can directly send the data to the company also, like this vehicle number and this is having this issue. So that type of EVs are coming in the third generation of EV, and some of the companies are now working on that also. So the third path was the thermal runway, like how to improve the thermal runway. Basically, the thermal runways, it depend upon the temperature condition for the internal circuit along with the external temperature of the climate also. So we have to select the batteries, and we have to select the BMS, and what was the type of BTMS is suitable for my battery pack, like a liquid cooling, air cooling system. So if we combine that, we will get a good performance of the battery, optimizations, qualities of the battery, life cycle of the batteries also, and you can also don't have to pay a lot of money while the maintaining of the batteries in EVs. Like batteries nowadays, some of the branded companies and some of the like Ather, Chetak, they are providing a 3-year warranty, 4-year warranties in the lithium cells. But some of the EVs like having a gel type of cell, lead acid batteries, they are providing a 1-year warranty because they already know that these batteries are go after a time like a 1 year and 1.5 year. So you have to purchase a new battery. So my suggestion, my personal suggestions, like whenever you are going to purchase an EV equipment, or for going for any projects, or for purchasing a EV, better to go for the best one, and as per your amount also, and as for the selection basis of what are the parameter and what was the performance you want from the EV. Like you are use that EV for the short duration of time, for a short interval of time, like that. So basically, the system function of BTMS in the basis of cooling, heating, insulation, and ventilation part. Like in Indian, as per the Indian climate surrounding, we are working on the basic functions on the cooling, insulation, and ventilation function. We are not preferring for the heating purpose. But in the foreign countries where the climate conditions are cold, we are focusing on the heatings also. Like they are providing a heaters in the vehicle that can maintain the temperature for the battery pack also. Insulation, like none of the cell can uh, uh, none of the cell can expose, and the none of cell can leak battery pack. So the basically when the insulation part, like when we are giving a liquid cooling, so there may be some issues like there is a leakage also. So they can also affect the battery pack while the maintaining. Then you have to go for the service stations. Basically the ventilations. We can using a four-wheeler batteries pack, and nowadays in the two-wheeler, three-wheelers like a pyramidal cells. Like in the cells are in the form of square shapes, cuboid shapes, and we don't provide that much space. But after longer, we have seen about the LFP cells when we are connecting them in series and parallel combinations. You see that the between the each of the batteries there are some space. That space is very much useful for the heating resistance, for the ventilation part of the battery. So somehow to like when we are using, we don't have that much space. So we are choosing the batteries like having a lithium polymer pouch cell, or in the pyramidal cells, you can see that they don't having that much space. So to overcome that also, we provide some ventilation space between the batteries so the air can flow through that. So the last topic is about today is about the BTMS. That what was the BTMS? So we covered about that BTMS is a battery thermal management. Basically, it manage all the thermal heat of the battery, and they are categorized in the three types: active BTMS, passive BTMS, and the hybrid BTMS. In active BTMS, the major parts are air and liquid. Where the liquid are in the two forms, direct and immersion form also. Where in the passive, they are having a two type like PCM. Second one is heat pipe, but we can basically use the PCM and heat pipes in major of the components, like for a small for a small two-wheeler vehicles. We see the passive components type only. We never use the active components. You can see that active components in the four-wheeler and three-wheeler. Like PCM having a subtopics like pure composite, carbon, metal, but we don't go that much. We will cover only the active, passive, and the hybrid part. Hybrid one was the one of the best part, like because they are having a combination of active plus passive, so they are more efficient and reliable as per the configurations, as per the performance, or you can say that is a 4x double useful than the active and passive cells. But still they are very costly. So some of companies are adopting that, and some of the companies are working on that how to make that system in less budget. So we'll start with the active BTMs. Like what was the active BTMs? Basically, active BTMs where we are forcing the air through the center of the batteries, or from the vertical side or from the horizontal sides, through the use of any equipment like a pump, compressor, fans, to cool that battery module. When the thermal runway was detected by the BMS, they can give a command to BTMS that they this to trigger the controller or to trigger the compressor. So then the fan will run away and the air can flow through the battery. So they can provide a they can provide a cool air between the batteries, so the heat is absorbed. Like in the passive components, when we talk about the passive, we can see that the battery pack, where in the two-wheelers also it is connected through the back of the motor. Like a back of motor is also having a shaft where one fan is there. When the motor is moving in the forward direction, the fan was moving as an exhaust, and they can help through the pass out the heat from the motor heat, which is passing through the stator winding and the rotor winding. Whatever the heat was generated in the motor, they can pass through the back side of the motor. Like that, that fan is directly placed near to the batteries also, so the air can circulate at the time of while the running of two-wheeler also. So the part of air cooling, you can see that is one of the block diagram of the Nissan company, Nissan Leaf. You can see that the air is passes through the interior. You can see the exhaust part where the air is entering, and how the heat is going to process. The compressed air is compressed air is given to the battery, and they are collecting back from the hot air, and they can pass out. Like we are using the air conditions and many of the components, like all the components, what are the exhaust part, we can collect the heat also to bypass the air through the batteries also in some of the small types of vehicle. But nowadays, when the companies are coming with this type of battery pack, like is having a full planned, a full performance parametric cell designed battery pack, you can see that in the this part, the liquid cooling part was also there. Like the purple color, this pipe was for the liquid cooling only. This pipe was for the liquid cooling, so they can flow the materials. Sometimes they are simultaneously provide the silicon gel glyconis between the pipes only, so they can don't attach with the each of the battery, and they can absorb the heat only. In this diagram you can see that the coolant oil is given to this purple color oil as a outlet. For the inlet is a blue wire, and for the outlet is a purple wire. So as the time to time you have to provide, or you can change the coolant materials of the between the batteries also, so they can don't affect the battery life of the battery. So the impression part, in the immersion part, there is a combination with the pump and cooling. Along with that, we are having a closed loop circuit in the immersion cooling. Like we having a reservoir. The reservoir always processing the same airflow through the each of the system, where the regulation part was there. Like heat can generate it, and heat can through the given to the heat through the pump, through the reservoir, and through the again they are cooling, and again they are providing the cooling to the liquid. But the immersion system are not that much efficient, but we are more we see this in the active and the passive cells. Like Toyota is using a passive natural convocation cells in their four-wheeler. Nowadays in the batteries, they are using the fan regulated systems also for the new EVs. But in the before of that vehicles, they are using the passive natural convocations. We are basically the passive components where the comes like air ventilation from the natural air. They provide a small pore holes. They provide a surface of the aluminum heat sink, so they can heat can dissipate and move. The heat can be absorbed by the aluminum, which can resist through the air to the environment. Like that type of things. Like they are having a passive components are basically two types: PCM and heat pipe, HP, like a phase change material. Like phase change material, basically phase change material name it says that we are changing the state of the material. Like if they are in the solid form, so you have to change them in liquid form, or maybe in the they are in that form of liquid, so you have to change that form into gaseous form. So that state change name it indicates that phase change of material. And second one was the heat pipe. So this was the phase change. Like you can see the block diagram where the PCMs are used to for the multiple physical phases. Like you can see that they are having a sensor act on it. They in the each of the battery cell pack, they can check the performance, and as per that on that particular part, the liquid forms and the gases which are present on the between of the cells, they will act on it, and as per that the thermal runway will work, and we will get that the battery will cool at that particular portion. Heat pipe. So I told that in the cylindrical cell. In the cylindrical cell, like you can see that all the blue are the LFP cells, and we are having space between all of them. So we can arrange that a heat pipe of aluminum pipes in between of them, and we can pass the air also through that, and we can through the pass the air through also that, and in the aluminum we are providing a liquid coolant, so that liquid coolant absorb the heat easily. So we can also passes the it is connected from the both of side, not only for the internal part, they are connected for the external part in the parallel part also, and we are getting this type of packaging systems in the entire battery pack to go like I have bought a battery pack and I have to go again for the thermal part. Basically, a battery pack which is having a sufficient range for like a two-wheeler, for a three-wheeler, or for a four-wheeler. That battery pack complete having the coolant facility, and basically we have to select as per the rate of the BM, as per the cost also, that how much BMS is useful and what was the operation of the BMS. Like some of the branded companies, they can collect that data like a BMW, Volvo, they can collect the data through the BMS and they can evaluate that what are the performance in the battery pack. Along with that, we are talking about the hybrids. Like what are the hybrid? Hybrid is a basically two type of mixture of the two types of BTMS, like active balancing and passive balancing. In the active balancing and the passive balancing, we will combine that and we will get the sufficient output. Like this one was the basic part where the PCM connections, like you can see that in the center of each of the cells, like 1, 2, 3, 4, 5, in each of cells, the orange lines are drawn, which are passing through the PCM's connections, and composes compressed air is also fan is airflow is also given to that battery pack, like having a PCM coupled with the air cooling method, or maybe if you provide a liquid cooling facility to the battery pack, so it's also having a connections of PCM with the loading PCM with liquid cooling facilities. Basically, a hybrid cooling method optimized tools for the controlling of the temperature in uniform temperature graduates, but to build up the performance of the battery. In the basics combination of PCM and air cooling and liquid cooling and the heat pipe, we will see that we are getting the mixtures of hybrid cooling. So hybrid cooling are best options, but again the cost is very high. So and it's take a quite more space also as compared to passive BTMS. So the still some of the research part and some of the theory part is going on the PCM, but the main questions came. So which one of the best BTMS that which we are going to prefer in the four-wheeler or for upcoming EVs also. So in hybrid BTMS, the combination of PCM along with the force air cooling tools that are better choice for the optimizing of the battery. So they can they can help to improve the life of the battery is also efficient. Heat resistance capacities also, performance of the battery also, and improve to if the battery is having a long life, so they can also affect to improve the driving range of the car also. Like you don't have to always go for the maintenance part, or you have to don't spend your monies for always for the maintaining purpose. So I hope I have done from my side, and this session is sponsored by the ISI India, Imperial Society of Innovative Engineer. So this is from my side. If you have any queries, any questions, so I will take the questions. I'm audible to all of you.
Anyone having doubt, they can ask.
अब वो पता है Hi everybody. So it was a great session that we have on battery management system. Thank you, sir. Thank you for your this session. So I'm Sudhanshu Sharma. I have my company into this battery management system, and I was just going through the presentation. So I just want to mention some of the points. Like we are having two battery balancing technologies right now. One is passive, one is active. Now,
Yes,
industry
sir.
is also going towards this active cell balancing technology. We know that it is one of the efficient technology in the market. So I just want to mention that yes, industry is facing this problem of fast charging infrastructure. As we know that fast charging, we have the adoption of EV increasing day by day. But what we need right now is a fast charging infrastructure. And for that, we need one of the efficient technologies into this battery management system. And this technology that we have is an active cell balancing technology that can work for the fast charging infrastructure. So I just want, this is the thing
Yes,
that
yes.
I just want to mention. And thank you for the.
No, no, no. I completely agree with you that active balancing will support the fast
Be the
charging.
future, yeah.
Yes, yes. But somehow, as per my means, my options, or maybe I said that my preference, that we always go for the fast charging that can damage the life cycle of the battery also. So we have to design that
Yeah, yeah.
battery as per that
That's.
C rate also.
Hmm.
So that's my
Yeah, yeah, yeah,
point
yeah.
to say that. I hope you will understand that if you go for the
Yeah,
always
yeah, I
for the
totally
fast
understand. I
charging,
just want to,
add
I
on
just
point.
want to give
I
a brief
agree.
understanding about the industry.
It's a good
Yeah,
point. So
yeah. It's kind of
it's
contribution. I
appreciable
just
from
want to
my side
contribute
also.
into it.
Okay, okay. Thank you,
Thank you
sir.
so much.
Okay, sir. Anybody having any questions, or should I wrap the session?
Sir, I have one question.
Hello,
I am
sir.
Sridhar speaking here.
Yes.
Sir, what are the current materials which are used for cooling purpose in terms of PCBs?
Like for the PCBs nowadays, silicon is using glycerin. One of the video I don't right now. I don't have that video, but I've seen some like in the PCMs when we are changing the state, changes the state. In that case, we have seen that the silicon glycogen material, which is very much using and which is very good for the PCM part. Like they can absorb the heat, and after when we are putting that in the space between the batteries, so they can change their shape and size, and they can come into the gaseous forms after the sum of time, when we are going for a 2 years 3 years, they can change their state also, so they can easily absorb the heat. So as per my consideration, PCM, the silicon glycogen was a good material for the PCM. Silicon glycogen and ethylene glycogen.
Thank you, sir. Thank you.
Okay. Ethylene glycogen.
Good evening, sir.
Yes, sir. Bol.
Sir, we all know that every battery has got internal resistance.
Yes, sir.
And in the lithium ion batteries, if the temperature is increased by say about 10 degrees, what is the effect on its internal resistance?
Basically, in the 10-degree temperature, the battery doesn't that much internal resistance, or I can say in the effect of the separator also, because when we are connecting the batteries, we are providing the charging and discharging the cell. Basically, ions are connected from moving from the cathode to anode, and that can make an internal circuit on the battery. So, in the 10 degrees Celsius, they don't affect that a huge amount, but maybe the battery is having a specification, like the battery is having a specification up to 40 degrees Celsius or 50 degrees Celsius. If we go beyond that temperature, though, then in that case the internal circuit break, and also the effect in the life cycle of the batteries, as well as the battery collapsations, like you can see the fluids are coming from that battery.
Okay. Okay, thank you, sir.
Okay.
Sir, one more question.
Sir, I have one more question. Hello.
Hello.
Yes.
Sir, I have one more question.
Yes, sir.
So regarding a model which is available for general purpose BMS in the market for any studies purpose or project purpose, can you name that model, sir, which is available in the market?
Basically, in the batteries, for a single cell of the batteries also, like for a over voltage cutoff or cutoff voltage of on a single cell, which is having a two cell BMS are also available in the market. And basically the hardware type of BMS, which is very much using in the projects and for the school projects, college projects. We can prefer the hardware projects like because in the engineering level they can easily relate with the electronics part and electrical part along with the embedded part also, like they are having an algorithm behind in the ICs and the microcontroller also. So as per that hardware part is good for the project and the college part. So that is from my side. Shall I wrap the session, or if you have any question, you can ask. Okay, this is from my side. I'm going to wrap this session. So further, my team will handle the situation. So I'm leaving the meeting right now. Thank you to all of you.
Yeah. Thank you, sir. Thank you.
Okay, hello learners. Thanks for attending the webinar. I hope this webinar helped you out for the upskilling and learning. Okay, so I'm so excited to introduce you about the ISIE India products and services that can transform your career and learning in the EV industries. So come take a look of a small video of ISIE India products and services. Okay, have a look.
Hello engineers, do you also want to expand your knowledge of electric vehicles and want to secure a good job in the automotive industry? Let me help you to get there with our online and offline products. ISIE India has been offering specific domain courses as per the industry demands with perks like pay after placement, no cost EMI, placement assurance, global wide certification by Automotive Skill Development Council ASDC and National Skill Development Corporation NSDC Government of India. We have range of courses in electric vehicle, computer-aided design and engineering, including postgraduate certification and executive PG program in EV, professional master certification program, specialization programs, fundamental programs, and internship in EV, CAD, and CAE. Our postgraduate certification program in EV is specially designed for the students with 120 plus online learning hours, 100 plus hours of industrial projects and internship to give exposure of various computational tools for hybrid electric vehicle applications. It is a 12 months assured placement course with pay after placement, thus encouraging the learning without financial constraints. The course is globally valid, certified from NSDC Government of India. Our executive postgraduate program in EV is specially designed for the working professional who want to upskill themselves or looking for a career change in the EV industry. With 120 plus online learning hours, 20 plus hours of industrial projects. It is a 9-month assured placement course with globally valid certification from NSDC and ASDC Government of India. Our professional master certification program in EV, CAD and CAE is specially designed for the undergraduate students to pave their career path by providing industry relevant skills with 100 plus online learning hours, 5 plus hours of industrial projects. It is a 6-month placement assistance course with globally valid certification from NSDC Government of India. Along with the courses for skilling, reskilling and upskilling, at engineering institutes across India, we are setting up a state-of-art facility, Center of Excellence for e-mobility research and skill-based education, which is equipped with research and project-based learning-oriented experimental setups. This Center of Excellence is not only limited to educate the students, but also it will be utilized for research, innovation and product design and development. It is a combination of 6 labs including EV powertrain training and research lab, battery BMS training and research lab, EV charging and battery swapping lab, software modeling and simulation lab, innovation lab and renewable energy lab. Each lab is consist of number of customized workbenches and machineries Few of them includes EV drivetrain experimental setup and motor testing workbench, hybrid drivetrain experimental setup with data logger, EV machine cutout section workbench, two-wheeler, three-wheeler, four-wheeler training workbench, battery load capacity testing, battery BMS with CAN protocol workbench, V2G setup, on or off grid work charging station, battery swapping, autonomous vehicle training workbench, solar power generator and software solutions, and many more. No matter from which branch you study, we commit to skill and assure you a success in your career. We have spread the joy on thousands of faces, becoming their partner along with the journey towards success. Join us and take advantage to unlock endless career opportunities.
Thanks, learners, for watching this video patiently. As mentioned, we have a proven track record of success, and our clients have seen significant improvements in their learning and career. So, any of you want to enroll in the course or ready to take your career to a next level? Kindly send us an inquiry to a QR code displayed on your screen. Those who are interested in the courses, only those have to send the inquiry through the QR code displayed on your screen. Thank you.
For course inquiry, please scan this QR code displaying on screen.